is Michael Thielens, and this is a machine I invented to try to get energy from a small amount of heat differential, and it turns it into energy. And how it turns into energy, we're going to demonstrate it here. We're going to prove it to you. And it's not me that's going to prove it. It's the actual demonstration of it and the mathematics of it, that we can actually power a house, we can power a home free, maintenance free, virtually maintenance free, enough heat from the restaurant to power the restaurant free for electricity for the entire life of the restaurant. The amount of heat expelled just from the ovens and the stoves can actually power the restaurant itself free. We're going to explain that exactly how it would work for a restaurant, how it would work exactly for a home. Right now, this is just an experiment. This only has 168 bimetal thermal springs in it, and it's going to take, this is much smaller of a version that it would take to power anything larger than a small light bulb. I'd like to explain this right now, if I may.
Go ahead.
Okay? This is the heart of it, that we can take one bimetallic spring and we can get enough energy out of it to lift 1 ounce, 1/2 inch. That's all it takes with when we're talking about a restaurant, we're talking about a single family home, we're talking about a lot of springs. But it doesn't take a lot of area, it doesn't take a lot of volume. Let's say for a single family home, it takes a piece of equipment the size of a refrigerator. And we were going to get into that, we're going to explain that in a little bit.
Okay.
Let's get to the demonstration.
All right.
This is one of those thermal springs. We're going to raise the temperature in here by 25 degrees, and you can see the difference it's going to make raising this 1 ounce weight. If we're getting luck trying to raise the temperature to right around 100 degrees. Okay, right there, and we'll actually see how quick and responsive these weights are. These springs are. .80 degrees is probably a little warmer. We're getting close to 1/2 inch right there. Give it another minute. That's good enough. 103. The weight rose a little more than 1/2 inch. Seems to be holding right there. But you can get an idea, and all our calculations are based off of one spring raising 1 ounce, 1/2 inch. This is going to be another test with 2 ounces. We're going to try to test and see if we get the temperature up to 105 degrees. It's currently at 88, a little warm today. It's 85, and the bottom is 88 again. I don't know why the discrepancy, but probably from the last test. But we're going to raise the temperature and see where we go from there. Again, we're working with 2 ounces. Try to get the camera to hold still. We're going to chop this up and see if we can get this into sections. This is just a video of two-way rotation to one-way rotation. Two-way rotation into one-way rotation. Capturing all the energy of the springs, heating or cooling. About an hour now, and it raised 6.5 inches. I just put a measurement on it. And that kind of concludes this test. We're going to do some more tests with heavier weights, but this is just one test to show you the strength of 168 thermal springs. Now, the one aspect of this machine that we're going to concentrate on, talking about, is, like I said, how we can power a single family home with absolutely no waste, no byproducts. There's one byproduct that I should tell you about, and that is that it reverses global warming 100%. Every bit of energy that this machine takes out of the air, from the earth, turns it into potential energy, and it's 100% reversal of global warming. It actually cools the air, it takes the heat from the air, takes the heat from the earth, and turns it into energy. I know that sounds exaggerated. This machine is designed to pick up 1 pound 5 inches. That's what it's calculated to do. I haven't been able to get there yet. I got 4 ounces, 6.5 inches. That's the best I've been able to do. These particular springs aren't exactly the right particular springs that I wanted to be using. That particular spring is something more like it. That come from an old carburetor, from an old Holley carburetor on a theoretical machine for a home. There's 50 springs in a row. There's going to be 50 rows to a rack. A rack's going to be the size of a radiator. Now we can get these rows much closer than they are ready to get. We're going to have 50 racks to the size of a piece of equipment the size of a refrigerator. That refrigerator is going to have a total of 125,000 springs. And all of these springs are working independently and together to create energy. And if that refrigerator size equipment will power that house, using the calculations from just that one spring of picking up 100 pounds a quarter mile in the sky. Of course, that machine has not been built yet, or I'll be demonstrating it. I have to show you this machine exactly like it is, because if it was completed in its housing, you wouldn't see one part. It's 100% insulated, and so it's not visible. Again, that machine with 125,000 springs, and then we're going to cycle. We're going to cycle the heat. The cycling of the heat is going to be 15 times an hour, every 4 minutes. We're going to heat it and cool it. That attic holds enough heat to power the house all night long, because we would use that heat that is accumulated in the attic instead of thrown away being used, and that would supply the heat during the night. Now for the coolness of the day, it's a little harder. There's a lot of natural things like a little pond, above ground pool, a little swimming pool, a kiddie's pool, and even a 1 degree variance will produce energy. 5 degrees, 10 degrees. There's a lot of places on this earth that have a natural degree, a large degree between night and day. Sometimes in the desert it's very warm in the day and very cold at night. That 125,000 springs can power that house. Now it'll produce enough energy, potential energy, to put a 100-pound weight 1/4 mile in the sky. Now that can be converted to BTUs, that can be converted to horsepower, and that can be converted into kilowatts. Do the mathematics. We're going to show you the potential of just one spring and how it does. And we went off of 1 ounce, lifted 1/2 inch with a 30-degree variant. You can power a restaurant very easily, because the restaurant throws away a lot of heat from the ovens and the stoves to actually power the restaurant for eternity. No waste, no byproducts, no pollution whatsoever. And again, it just 100% reverses global warmth. A ship in the ocean is an ideal candidate, because there's a lot of heat, especially in parts of the world, above the decks on the steel plates, and there's the cool water in the ocean. So a ship is a very potential candidate. The machine over there was one of the first tests. Every time that we built the machine, it evolved. It was obsolete time it was done. This machine happens to be working pretty much like a clock. Someone asked me if this could be used in Alaska, and the answer is absolutely yes. Let me give you one example. If there was a location where the air temperature was 20 degrees below zero, but there was a lake, a river, or the ocean nearby where the water was 35 degrees above zero, there's enough energy there in the two different temperatures to power a city. Someone also asked me if it could be continuous, a continuous force, like an engine, like turning a crankshaft. And absolutely yes, but the machine would have to be broken down into different sections where one part is heating, the other part is cooling, or in different phases of the such. And it could be just a phase motor, just like an electrical motor or a gasoline motor. soon as this gets up to 100 degrees, we'll drop it back down. We're going to try to cycle it every 5 minutes. I should put this on a, but I'm going to edit it. Okay. The heat should be going in there now. Yep. I'm going to cut back to the temperature going up. 78. Go back over here. Okay. Temperature's right around 80. 79 at the top, 82, 79, 85. It's warmer in the bottom, 95. Get up to 100. We're at 82, 87, 84, 91. We're at 100 and 105 at the very bottom. We'll get the temperature up a little more. Hundred and 103, 109, 99, 88, 93. Another 30 seconds. We'll just keep going until it rises. The spring shows 79 degrees. That's right at the 3-minute warning. We're at 81 at the top. 87, no, it's 87, 98, 92, 104. I'm going to cut back and show you the mechanics of it real quick. Come back. It's still rising. We're at 105, 99, 92. Okay. Still rising. Still rising. Okay. We're well above 100 on most of the temperatures. I'm going to put it to cool air now. I have to put down the phone. Cool air right now. I'll give you a shot of the temperatures. 94, 111. The 103 is the spring itself. It's up by itself. Just for a measurement. Again, the top thermocouple is 94, then 111. 103 is the spring. 112, 112, 130, and 137. Okay. We're just gonna. Now it takes a long time to cool down, so I'm gonna shut it down. I'll try to get this smooth out right there. The process of the springs expanding is stopped, so it's completely stopped. We'll let it cool down. I'll come back to you in 5 minutes, 4 minutes. This is going to be with 6 ounces. I'm not going to videotape the whole thing because it's too long. I believe the glass is just too much mass and it takes too long to heat up and cool down. We're going to put a piece of insulation in place of the glass on later tests. But this one test is with 6 ounces, and we're going to see how it raised that 4 ounces, looked like 4.5 inches. We're going to give it a test right now with that 6 ounces and see where we go. It's going to start climbing about right now. 100 degrees. Excuse the glare, but we'll give it. I'll tell you, I'm not going to bore you with a long thing, so we'll just tell you what's going to happen. Maybe I'll video tape when it goes up. That was my best results up to date. We got, with 6 ounces, we got 5 inches, just topping out 5 inches, and still got a little more to go, still cooling down. And it was the quickest cycle that I had. Using the insulated board, all we were heating is the springs and the carbon fiber rods. There was some loss of heat, but definitely it was the best results to date. 6 ounces, 5 inches, easily, and still going. This is a test with 1/2 pound. We cycled it 3 times, and it raised this 1/2 pound just a little over 1 foot. The equipment is not complicated. It's not expensive to build. It is 100% recyclable, every part of this machine. Any heat source is a source of energy. A machine like this, of any size, can capture that energy, convert it into whatever form of power that we're looking for. Be it a constant force, be it a generator. It's just mechanical, and it's potential force. This is a test with that 1/2 pound. We used a white background so it'd be a little easier to look at. Again, we did the test, and it was about 4 inches every time we did the test, and we cycled it 3 times. We got a little over 1 foot. If you fast forward it, you can actually see it moving in a sped up situation. And this particular piece of equipment, we have a hard time cooling it down because there's so much mass in there. We're just not cooling down the springs, we're cooling down the ductwork and the heater and several other things. So we do take these videos into little sections. Once again, there is no pollution whatsoever. There's no byproducts. The equipment is 100% recyclable. It's not expensive to build. It's not complicated. There's so much room for improvement. There are thousands of natural heat sources, both man-made and natural. Of course, the sun is the major heat source for the earth. Equipment like this can be used to power a single-family house. It can be used to power a city if given in the right situation. Always, it's clean energy. Absolutely no pollution whatsoever. There's no byproducts, and it does reverse global warming. And I just want to say thank you for watching this video.